This video is going to look at the low pressure switch operation with a thermal expansion valve system. Now, the switch, if it has one, is going to be mounted on the low side of the system. And I have to stress that when it comes to the air conditioning protection switches, whatever a manufacturer chooses to use is what they may or may not use. What is standard issue is the TXV system will have a thermostatic switch, as discussed in previous videos, but beyond that, it is up to the manufacturer. Got a picture here, basically an ANSI drawing of a low pressure switch. Now the cutout pressure can be anywhere from 3 to 24 psi, totally depending on the switch and depending on the application. You need to make sure you're getting the right part number going into the right system. And again, over here, looking at our lower than normal pressures and the common causes, there are more causes. I'm just going to look at the three most common, that being a low charge, no charge, or low ambient temperature. Back to those basics we go again. We're going to look at a thermal expansion valve system, relative state and pressures, just a quick overview. Starting with what are our normal pressures. Low side 10 to 40, high side 100 to 250. What's normal totally depends on the heat load. At the inlet of our variable orifice, we have a high pressure liquid. And of course, on the other side of the orifice, we have a low pressure liquid. As that refrigerant winds its way through the evaporator, it absorbs heat. And by absorbing heat, that refrigerant will become a vapor as it exits the expansion valve and evaporator. I'm not going to put a question mark on vapor here. We must have vapor here because there's nothing between the outlet of the evaporator and the inlet of the compressor other than a rubber hose that would allow any liquid to absorb heat and turn to vapor. Reminder again, AC compressors do not like liquid refrigerant. It's hard on the reed valves. Now, difference from the CCOT, we've got this variable orifice, and what it does is monitors the temperature right at the outlet. And by monitoring temperature, that valve is able to open and close as required to either restrict refrigerant flow or allow more refrigerant flow. The valve can never completely close off. It can go to a minimum flow, but that's all it can do. And coming out of our compressor, we have a vapor under high pressure. And coming out of our condenser, if everything's working right, we have a liquid at high pressure as well. And that continues to circulate all the way back to the inlet of the orifice and repeats the cycle. Let's look at our first scenario, and we're going to look at each of our scenarios with and without a low pressure switch of some sort. Now this scenario we start with no charge, and the reason we have no charge is because a hose has broken and all our refrigerant has gone to atmosphere. Our pressure is 0 psi in the system. Now, importantly here, ambient temperature of about 21 Celsius and sunny. If we hop in this truck and fire it up after it's been sitting in the sun for a while, the evaporator is going to be hotter than the outside temperature. So I'm going to pick about 26.7 Celsius, 80 degrees Fahrenheit. If all I have is a thermostatic switch, which is the basic switch that works with a TXV system, if remember again how a thermostatic switch works, this bulb area in here is all full of refrigerant. That bulb is going to be sensing a high evaporator temperature. It is going to close the contacts right here. And the compressor clutch is going to receive the amperage it needs to engage the compressor. Now this would be a very, very bad thing because especially with a hose broken, what we've got here is dirt, water vapor and whatever other contaminants are around are going to get drawn into that compressor and are going to destroy it from contamination. Now, the solution, we're going to look again at a no charge and still ambient temperature 21 Celsius and sunny. We've still got the broken line. But what we're going to do is we're going to put this low pressure switch in place now. We're going to wire it up as simple as possible. From the battery, we go to the supply side of the thermostat. Now, just like before, all the thermostat knows is that the evaporator temperature is too high at this point, and it wants the compressor to pump. So the circuit here is going to close. The thermostatic switch will close from the pressure inside the diaphragm pushing on the contact. However, now that we have a low pressure switch over here in the mix, that low pressure switch is going to cut out somewhere between 3 and 24 psi, totally application dependent. You have to make sure you've got the right switch going in the right system. Regardless, with no charge at all, we will have 0 psi in the system. This switch is going to cut out. The contacts right here are going to be open, and that is going to stop our compressor from pumping. Let's look at now what happens with a low charge. And again, we're going to look at this in two scenarios. This one without a low pressure switch, and the next picture we'll put in a low pressure switch. We've got enough refrigerant in the system, barely enough just to maintain 1 psi on the low side. That is not going to give us proper cooling. So in this picture, I've said the evaporator temperature might drop down to about 21.1. It'll just match the ambient temperature outside. Thermostat, again, is all it knows is the evaporator is too warm. It wants the compressor to run, so it closes the contacts, and amperage is allowed to flow up to the compressor clutch coil and cause that compressor to pump. Now, why is this a problem? Well, right here, oil is circulating with the refrigerant at all times. Most of the oil will stay in the compressor sump, and of course some of it will be in the condenser, evaporator, dryer, but we require the proper amount of refrigerant flowing through the system to keep the proper amount of oil flowing through the system, because there are critical parts of the compressor that require that oil circulation so that they don't fail. Now this is the exact same picture essentially as the last one. Again, we've got 1 psi in our system. We're dealing with a low charge, and we've got a thermostat here, and all it knows is the evaporator is too warm and it wants that compressor to pump. So the switch contacts on the thermostat will be closed. However, what we've done now is we have put a low pressure switch into the system as well. Again, that contact cutout will be 3 to 24 psi, switch dependent. We've only got 1 psi, therefore the low pressure switch contacts are going to go open and prevent that compressor from pumping and possibly damaging or destroying itself from lack of oil circulation. Let's look at a third cause of lower than normal system pressures, that being low ambient temperature. We're almost minus 24 Celsius. Let's assume the truck has been sitting outside overnight and our evaporator is also at minus 24 Celsius, which corresponds to about 1.9 psi in the system as that refrigerant contracts because it has no heat available. The thermostatic switch is doing its job, and it's got the contacts in the switch open because all it knows is the evaporator temperature is too low. I want to stop the compressor from pumping. Why do we care if the compressor runs at minus 24 Celsius? Well, as always, we have to remember compressors do not like liquid. Now, if I've got a system sitting at minus 24, there is no heat available to be able to vaporize that refrigerant. And if I can't vaporize the refrigerant, I'm going to send liquid to the compressor and slug it and blow up the reed valves. Let's add this time a low pressure protection switch as well. What we're going to end up with really is double protection in a low ambient temperature situation. The thermostat knows that the evaporator temperature is low, so it tells the compressor to stop pumping. And the low pressure switch is monitoring the low side pressure directly, not temperature, but pressure assuming temperature. And it's only seeing 1.9 psi, and therefore it goes open as well. So in summary, a low pressure switch on the low side of a thermal expansion valve system is going to protect us from low charge, no charge, and give us double protection from low ambient temperature. And a good generic across the board cutout pressure for these switches is somewhere between 3 and 24, depending on the truck, depending on the system.